Astronomers just pointed the James Webb Space Telescope at a faint red dot and found something that shouldn't be possible. It looks exactly like a giant star, but it is shining with the power of 100 billion suns, which is roughly 100 billion times too bright for any star to ever be. The object is called Moam BH Star 1, and it dates back to just 660 million years after the Big Bang, making it one of the earliest things we have ever directly studied. It was found completely by accident during a JWST survey that was actually just trying to catalog the most distant galaxies in the universe. At first, it looked like a huge, cool, reddish star, the kind of spectrum you would expect from something like a red giant. But when the team led by astrophysicist Rohan Naidu ran the numbers, the energy output made no sense for a star of any kind. You cannot power something like this with nuclear fusion, which is the energy source at the heart of every single star we know. Fusion has a hard ceiling on how bright it can burn, and this object blew straight through it. So the team modeled a different idea entirely. What if this isn't a star at all, but a black hole about 100,000 times the mass of the sun, wrapped inside an enormous, extremely dense cocoon of hydrogen gas, roughly the size of our entire solar system? In this picture, the black hole is doing the job that fusion normally does. It rips gas apart and heats it to extreme temperatures, and that energy gets trapped and reprocessed by the thick shell of hydrogen around it. So instead of looking like a violent black hole, the whole structure glows softly, almost like a star's surface. The clue that gave it away was hiding in the color itself. The astronomers found a massive drop in brightness at a very specific wavelength called a Balmer break, and this one was far more extreme than anything ever seen in a normal population of stars. That steep break meant the reddening wasn't caused by dust like it usually is around young galaxies. It was caused by an incredibly dense wall of neutral hydrogen gas, so thick that it's considered Compton thick, meaning it's dense enough to swallow even hard X-rays that normally cut straight through gas clouds. This matters way beyond one strange object because JWST has been finding thousands of these tiny red dots scattered across the early universe, dubbed little red dots, and nobody could fully agree on what they were. Some looked like dusty baby galaxies, others looked like impossible black holes that grew too big too fast for physics to easily explain. Naidu's team argues that this black hole star may be the hidden engine inside nearly all of them. If every little red dot is actually a black hole cocooned in gas just like this one, then we may finally understand how supermassive black holes manage to grow to millions or billions of solar masses within the universe's first billion years. Normally, a black hole can only feed so fast before its own radiation pushes in falling gas away, a natural speed limit called the Eddington limit. But wrap that black hole in a dense enough cocoon, and the gas itself can trap the outgoing light and keep feeding the monster far past that limit, which could explain the almost cartoonishly fast growth we see in the early universe. This same model even helps calm down a bigger controversy. Some of these little red dots seem to have black holes so oversized for their galaxies that a few scientists claimed JWST had broken cosmology itself. But if their black hole masses were being wildly overestimated because of how light scatters through these gas cocoons, the crisis quietly gets smaller instead of bigger. None of this is fully settled yet. Other researchers have proposed rival ideas, like enormous, short-lived supermassive stars shedding their outer layers right before collapsing into black holes. So the debate over what these red dots really are is still wide open. But for now, this black hole star stands as the clearest physical example we have of the process that might have built the monster black holes sitting at the center of galaxies today, including our own.